Hello, everyone online. I just said hello to everyone in the room. Our next speaker is Mr. Chad Sperry from Western Illinois University. Chad, I made you a presenter. You should have rights to start sharing your screen if you so wish.
Hey, thank you, Cassidy. Can everybody hear me okay? You hear me, Cassidy? Okay. Well, thank you to IDOT for this invitation, and thank you for hosting a GIS Day event for Illinois. It's greatly appreciated. My name is Chad Sperry. I'm the director of the GIS Center at Western Illinois University, and I've been working with the state on their next generation 911 GIS project for about 3 years. And when Cassidy approached me about doing a talk, this was kind of the logical choice, was to provide an update of what is going on in relation to Next Gen 911 in Illinois. So a few the topics that I'm going to be talking about, an overview of what is Next Generation 911, a breakdown on our workflow tool that has been designed in conjunction with ESRI, some tips and techniques for accessing neighboring data to assist with the development of these statewide data layers. And then we're going to get into a little bit of recommended and strongly recommended data layers and workflow mechanics. So what is Next Generation 911? Next Generation 911 is basically a means to deliver emergency calls, messages, and data to the appropriate PSAP, or Public Safety Answering Point, and other appropriate emergency entities based on the location of the caller. So 911, like a lot of technologies, has aged, and Next Generation 911 is the means to bring the whole system up to date. And this is being done on a state-by-state basis. And Illinois is quite a ways along now with our effort, and GIS is really at the center of Next Gen 911. So why do we need Next Gen 911? It'll do things that we only dream of today, like seamlessly working with other public safety agencies and other public safety colleagues across the country. But best of all, it'll transfer highly accurate data in real time, allowing call takers and dispatchers to send the right resources to the exact right location as quickly as possible. So again, we've got an aged system that's using antiquated databases, and Next Gen 911 is going to bring that system up to date. So that's just a little background on what Next Gen 911 is. And I mentioned the importance of GIS in Next Gen 911. So GIS is what's called a functional data element for the overall operation of the Next Gen 911 solution. And there will be a transition, from the current legacy databases, we call that MSAG, a Master Street Address Guide, and ALI data, to geospatial data, which will be used to route and process 911 calls in the 911 Next Gen 911 environment. So basically, today, calls are routed to public safety answering points through switches and towers that are programmed based on where that call is being routed through to go to the proper PSAP. So based on location, where's the closest agency? And Next Gen 911 will change that so that it's a true geospatial means. It'll look up the location of the caller and do an overlay operation on the GIS data that will allow that call to be routed in a much more accurate and quick fashion. So what have we done to date? Well, we've built a standard that we're implementing statewide, and that was done about 3 years ago. And in building on the standard, ESRI was brought into the mix, and they launched a hub for us, a private hub, back in September of 2020. And then on top of the hub, there's been a workflow in ArcGIS Pro that has been created that was launched this May. And I'll give an overall update on where the state's at with uploading and accessing of the different data layers to date. So we have identified this category of user called a data maintainer. And basically the data maintainers are those individuals with the 911 PSAP. Some of you in the room might be or probably are data maintainers for your local agency. If you're not, talk to your PSAP, talk to your 911 folks and see if there's something that you can do to assist with data or with expertise. So these data maintainers since 2019, since we developed a standard, and this standard is a nationwide standard, we just adopted it from NENA. These data maintainers have been working to prepare what we call the 7 required data layers. So there's required data layers, then there's recommended and strongly recommended data layers using this standardized model. And these data layers that are required include the PSAP boundary, which is a lot of times the county boundary, especially for downstate counties. Provisioning boundary, which again is usually close to a county boundary. Up in the metro area, it can deviate from that. The police layer, which is who provides police service in different parts of your PSAP or your public safety answering point. Fire and EMS boundaries, so those are polygon layers. And then we have kind of the meat of the data layer development, which is our address points, which are point data, and our street center line, which are line layers. So a lot of agencies already had these data layers in-house, and this next gen initiative has been one of standardization. So the end goal is to have a merged mosaic data set of all of these data layers statewide for the whole state of Illinois. That's seamless, so you can understand the importance of standardization in this process. We did have some training for the data layers, and at least one data maintainer from each 911 system was required to complete the training. That was as part of the training plan that was distributed back in June of 2020. The training plan had basically 2 categories. So if you were an experienced user of ArcGIS and GIS software, you were required to take migrating from ArcMap to ArcGIS Pro. And again, everything that we are doing is in the ArcGIS Pro environment. And then there's another class, creating and editing data with ArcGIS Pro. If you were a new user, we had a class for ArcGIS Pro Essential Workflows and creating and editing data with ArcGIS Pro. So a little bit different sequence depending upon your expertise. All right, this is going to transition into the workflow tool that I had referenced and just kind of give you a little bit of overview for those of you that aren't data maintainers so that you can see how this process works that we're using to standardize the data. And again, this is just for the 7 primary data layers that we talked about just a minute ago. So step 1 is setting up your layer mapping and domain mapping tables, which indicate the name of the PSAP, which PSAP it's coming from, so your host agency, your county name, and then it outlines your source layer name. So what's your layer name currently? So maybe your address point layer is called addresses, and the destination layer, what we're standardizing that name to is address points. So it outlines the layer mapping for each layer, and then also any domain values. So you can imagine we've got a lot of domain tables, drop-down tables to work on this standardization. And if you have any domain values that are different than domain values in the tables, you have an opportunity to map those domain values as well. So that's kind of step 0. Then we get into step 1, which step 1 is creating a geodatabase model. So it's actually creating that empty shell of a geodatabase using an XML schema that's downloaded through the tool. And this basically just tells the data that's going to be loaded in step 2 where to go, and it outlines the names of the fields and the types of fields and the names of the data layers. This is the geodatabase that ultimately will be submitted by each individual agency to the hub at the end of the process. Step 2 is loading the data into the geodatabase model. So you're transferring that data from your local database into the database that you created in step 1. And you're going to repeat this step for each of the primary data layer, each of the required data layers that you've created. Step 3 is a QA/QC step. So this is just looking at a series of topological and attribute validation checks that everybody is having performed on their data, and creating an error table that you can use in step 4 to correct your source data. And we're recommending that you go back to that source data and correct it there, and then reload your data layers into the geodatabase in step 2, and kind of iterate through this process as you're working on cleaning up your data, your address ranges in your street centerline file, road names in your address point layer, etc. So once you have fixed these errors, you move on to the next step, which is step 5, which is revalidating your corrected data. And at this step, there's an option to create a connection line layer that basically draws a line between where your address point would geocode on using the ranges of your street centerline file and the actual location of your address point. And that's just an additional QA/QC step that you can find parity issues, addresses that are on the wrong side of the road, etc. And then step 6 is actually uploading the data to the private portal that has been set up. And we have set up error percentage rates that you have to meet in order to be able to upload your data layers. So right now we're updating that from 20% to 15%. The end goal is 2%. So I'll show you the schedule of when we are changing the percentages. So basically, as time passes, the expectation is that the users improve on the accuracy of the data until we hit that 2% error mark. And that's per NINA standards and working with the vendor that is building this private network. So once you've completed step 6, you have successfully uploaded your data to the NextGen Hub. And the data is available to any users that have a private hub account, and they can download your data, load it in with theirs, and compare and go to town with these data layers. So that takes me into the next portion of my presentation, which is accessing your neighbor's data. So as you can imagine, a lot of GIS entities are islands, by counties. And we have been doing a little bit of work. Peter Schoenfeld up in Lake County has downloaded all of the provisioning boundaries that have been submitted and performed a overlap and gap analysis on them. And what he has found so far is that every single county or PSAP has gaps and overlaps between their neighboring data layers, and those gaps and overlaps need to be fixed and tightened up. So we're working on a series of steps that outline how you can work with your neighboring data layers to reduce these gaps and overlaps. This is easy to do in ArcGIS Pro. You connect to the ISP, the Illinois State Police Hub, and add your data and your neighbor's data to the map. Be aware that a lot of counties have surveyed their county boundary. And, one option is to use national data sets because they are topologically correct, but they may be, not in line with the surveyed county boundaries that either you have or your neighbors. So communication is really key at this step, working with your neighbors, having those clear lines of communication to make sure that we don't miss anything with our neighboring data. All right, now I'm going to move into the recommended and strongly recommended layers. And this is just a sampling of some of the recommended and strongly recommended layers. And right now, we're not asking for those. There's no process through the hub submission that gives users the ability to upload these data layers, but this is something that's coming in the near future. So parcel data, there is a definite need to have a statewide parcel data set, and this is something that we're talking about through this 911 project, but it's definitely in the preliminary stages at this point. Bodies of water, we can get bodies of water through the state clearinghouse or through the National Hydrology Dataset, the NHD. Park boundaries, you could imagine it's important to have a background map that has park boundaries, and depending upon the level of government, this data may be available from the state, it may be available from the National Park Service, but if they're local parks, you're probably going to need to work with your local city or your local park district to get those data layers built. IDOT interstate and tollway data. We've worked with IDOT. IDOT's been great in providing interstate mileposts, and we've got that data available for download, and tollway mile markers as well are available for download. River miles, the U.S. Army Corps of Engineers has river mile for those counties and PSAPs that are on a river available for download. Railroad crossing data from the Federal Railroad Administration. U.S. Department of Transportation has a lot of different data layers. Fire hydrants is a strongly recommended data layer that a lot of times is available from your Public Works Department or from your local fire department. And then PLSS, or your survey boundaries, your section lines, are available from the state clearinghouse. All right, we're going to talk now a little bit about workflow mechanics. And as I mentioned, we're working with ArcGIS Pro, and the last update of the workflow tool, that tool that I went through the steps, the 6 steps with, was developed using 2.7. That created some functionality with geocoding that was not backwards compatible. So you must have at this point ArcGIS 2.7 or higher, and the most recent version of ArcGIS Pro is 2.9. Workflow management. This tool will overwrite anything that you had previously uploaded. So if you run through that tool again and upload your data, it's going to overwrite the existing geodatabase that's in ArcGIS Online or the hub. But it only do so when the file name matches. So this is kind of a little nuance that we're working through with all the users. As we have, advanced the tool, we have given it new version numbers, and we want to make sure that everybody understands that when the version changes, we might leave orphan data sets out in the hub, and those need to be cleaned up. Coordinates and transformation. So as was discussed earlier today, the state has a single zone in the works, and 33 LDPs that are being or have been created. We're using WGS 84 as the default. So we are transforming all of our data into WGS 84 from State Plane or from UTM or whatever that source data was stored in. So you need to make sure that your data, when you're loading that into Pro, is the first data that's loaded, because we've run into, and we're hearing rumors of some datum transformation issues that are causing shifts of up to 3 feet. And that can be a problem, especially when we start working with our neighboring data. So the other best practice, and we're kind of working on this issue right now, it's on our radar, is to make sure that your coordinate system and datum are defined in your geodatabase and in your source data. National Address Database. So the NAD is hosted by the U.S. Department of Transportation, and they are very interested in obtaining statewide address data layers. Now, we're aware that sharing agreements need to be in place, and Cindy Barber Brelli from ISP, she's the head of the overall Next Gen project, is looking into ways to ensure that you know, any data sharing is in compliance with any local policies. But the NAD at the USDOT is used by Google, it's used by Apple Maps, Google Maps, Apple Maps, and others as a way to standardize and add in local address data. So that's something that's on our radar as well, is providing this data at some point in some fashion to the NAD. All right, so I mentioned that I was going to show the status, and this is a little bit dated, maybe a week or 10 days, but as of right now, there are 129, so there's 102 counties in Illinois, but there are 129 PSAPs, or 911 systems. A lot of counties have multiple PSAPs. And out of that 129, 105 have submitted data layers, and you can see the graphic over here on the right side of the screen. And that's a total of 406 layers, and this represents 55% of all of the data layers that we have requested. And again, these are the required data layers, those 7 core data layers. And these 406 layers have passed with the 20% or less error rate that we've got specified at this point in time. But keep in mind that the go live requirement, and go live is shooting for next June, is a 2% error rate. So many of the PSAPs and counties have already hit that 2% rate, but that's coming. And here's the overall Geodatabase workflow submittal schedule. So you can see that we've got different dates. Some of these dates have already passed for the error rate percentages. So if you look at the bottom right date there, that's that far right column is our final error rate, final load percent. That's our 2% goal. And we want to have the address point and road centerline comparison done by February of 2022. That's coming right up. We want to have the comparison of legacy records to the road centerline done by April of 2022. And the comparison of legacy records to address points done by May of 2022. That's our goal that we're shooting for, and I think we're going to hit that goal. So it really is amazing to be part of this project. It's, to my knowledge, the first time that we're working with this many entities, individual entities, to get that local data, that really rich local data in a statewide system. And it's really gratifying to be part of this project. So with that, I'd be happy to take any questions that you guys may have.
Does anybody have any questions in the room? Don't think we do, Chad. Thank you very, very much.
Thank you.